Hello audience, my name is Azhetova G N. I am a physics teacher at Nazarbayev Intellectual School of Astana. Today I am going to explain about scalar and vector quantities in physics, and I want to share with you one approach to teaching from my experience. I want to give you some little demonstration about to show distinct between scalar and vector quantities, how it is important. For example, I have here is 200 grams weight, and it's suspended from scale. In our case, it's a dynamometer. The scale measures the number of force in from Newton, and so if these are 2000 grams and this measured number of newtons, and it's scaled right about 2 newtons, is the weight of this? No question. I could ask you in this. Let's say you bring another dynamometer. I bring in another dynamometer and I attach the scale to it. And now I have two scales, dynamometers, and I lift them directly up. What should each of the scales read? And you are thinking it's 2 newtons. So each one should read 1 newtons, about 1 newtons. The right answer, yes. Each of the scales weight right at about 1 newtons, about. And so that should make sense to you. In other words, 1 plus 1 equal to 2. The problem becomes when she starts to change the angle. And so what I am going to do, I am sure this will go off screen, is I am going to start to hold this at a different angle. And so if I look like right here, I know or find that it's at 50 or 1 grams, 1 newtons, and so I increase the angle like this, we'll find that will increase as well. And so 2 newtons, when I get it to angle like this, I have 2 newtons weight, and it's being supported by 2 scales now that I are reading 2, and it's going to vary as. And so the question becomes to do to math. 1 plus 1, it's equal to 2. 2 newtons plus 2 newtons don't equal to 2 newtons. I suddenly have 1 gram weight being supported by 2 scales that are each reading 1 newtons. And so this doesn't make sense, of the math doesn't make sense. And the reason why is that we are trying to solve the problem from a scalar perspective, and we'll never depending on the angle that we lift of them off. So to understand this in a vector method, so we will say there is a weight like this, and we will say that is a 2 gram weight, and then we have 2 scales, and each of those scales are pulling at 1 and 1. So this is one vector and this is another vector. We have the balancing of the weight with 2 weights that are on top of it. We have a force in that direction of 2 newtons. So we have a force down and 2 newtons, but we had a force of 1 newtons in this direction, and the force of 1 in that direction. And so if you start to look at it like a vector quantity, imagine this, that we got a weight right here, but you have to have 2 people pulling on it. And so it's like this tug or war, where it's not just in one direction, but it's actually in 2. And so you can start to see how these forces are going to balance out, but only if you look at it from the vector perspective. And so the reason I like to start talking about vectors and scalars at this problem is that you could never solve the problem if you are going to go at it from a scalar perspective. And we are going to do some really cool problems. Let's say I am sliding a box across the floor, but how often do you slide a box across the floor and actually pull it straight across like that? you normally pushing it at angle, and once we start pulling it at an angle, it becomes a totally different force, and we can't solve problem in a scalar way. We have to go solve it from a vector perspective. And so that's the importance of vectors. Now, it's a huge thing. So there are lots of things that we can measure in physics. Now I am going to continue our topic about vector and scalar quantities in physics. All physical quantities they will meet on the course are classified as a vector and the scalars. It is important to know any quantities is a vector or a scalar. Scalar quantities are those that have magnitude or size but not no direction. Vector quantities are those which have both magnitude and direction. Velocity and speed have the same symbol. Commonly used vectors and scalars in physics are, for example, two vectors: force, displacement, velocity, momentum, acceleration, gravitational field strength, electric field strength, magnetic field strength, and area. Scalars: mass, length, distance, time, volume, temperature, speed, density, pressure, energy, work, power, and current. Velocity and speed have the same symbols. The direction of an area, in this case, is taken as being of right angles to the surface, with current having current. Why current is a scalar? Because with current having direction, you might think that it should be vector, but is not. It is ratio of two scalars, charge and time, so it cannot be vector. It is important to know whether any quantity is a vector or scalar, since this will affect how the quantity is treated mathematically. Representing vector quantities. Vector quantity is represented by a line with an arrow. You can see in this picture. The direction the arrow points represents the direction of the vector. The length of the line represents the magnitude of the vector to the chosen scale. When we're dealing with vectors that act in one dimension, it's a simple matter to assign one direction as being positive and the opposite direction as being negative, as you can see. So if one force acts upwards on an object and another force acts downwards, it is a simple matter find the resultant by subtracting one from the other. For example, on a body act two forces: upward tension 20 newtons upwards and weight downwards by 15 newtons. But the resultant force, it's clear that is the upward length of tension vectors is longer than weight. Therefore, its object can't be in equilibrium position because the resultant force equal to 5 newtons and directed to upwards. Then, adding and subtracting vectors. When adding and subtracting the vectors, account has to be taken on their direction. This can be done either by scale drawn graphically or algebraically. For example, there are two ways of adding two vectors. Parallelogram method and triangle method. For triangle method, shift B, you are given two vectors, A and B. How you can add two vectors? Shift B parallel to itself so that its beginning point touches the end point of A. Join the beginning point of A to the end point of B. This is a vector sum of these two vectors is equal B to third vector C. Shift B parallel to itself to that is beginning. It's other way to add two vectors. It's a parallelogram method. For example, shift B that you given parallel to itself so that its beginning points coincided with the beginning point of A. Complete the parallelogram whose two sides are A and B. Draw the diagonal of the parallelogram which starts at the beginning of A and B. This is diagonal is A plus B. Subtraction of vectors. Subtraction is similar, but you change the direction of initial vector B opposite side, and you can find the minus B with same length. And the same procedure you should do. And the vector A minus B is the vector from tip of vector B to the tip of vector A, as you can see in this picture. For example, example questions, you can solve this problem. For example, body moves in a circle of radius of radius 3 meters with a constant speed of 6 meters per second. The velocity vector at all times tangent to the circle. The body starts at point A and proceeds to B and then C. Find the change in velocity vector between A and B. It's next slide. You can see. You can see in these vectors. This one. Circle. The body starts at P and proceeds to B and then C. Find a change in velocity vector between A and B and between B and C. It's a similar examples. You can change. You can use this rule to find the change this velocity in this case, as you can see in this picture. Other approach is scale drawing, graphical approaches. How you add two vectors that are given, B1 and B2. Adding two vectors B and B2 which are not in the same direction can be done by forming a parallelogram to scale. Make a rough sketch of how the vectors are going to add together to give you an idea how large your scale needs to be in order to fill the space available to you. This is a good idea when you are adding the vectors mathematically too. Having chosen suitable scale, draw the scaled lines in the direction of V1 and V2 so that they form two adjacent sides of this parallelogram. Complete the parallelogram by drawing in the remaining two sides. The blue diagonal represents the resultant vector in both magnitude and direction. For example, two forces of magnitude 4 newtons and 6 newtons act on a single point. The forces make an angle 60 degrees with each other. Using a scale diagram, determine the resultant force. Don't forget that the vector must have a magnitude and a direction. This means that the angle is just as important as the size of the force. Scale 10 millimeters represents 1 newtons, and you choose one point that labeled with red color, and you choose use parallelogram method and transfer two vectors 4 newtons and 6 newtons, and find the diagonal of this parallelogram. It is the resultant force, the resultant force, the sum of the two forces. Length of resultant force equal to 87 millimeters, so the force equal to 8.7 newtons. An angle resultant makes with 4 newtons force equal to 36 degrees. It's the same was example about circle how you can use the rule of subtracting the vectors. A body moves in a circle of radius 3 meters with a constant speed at 6 meters per second. The velocity vector is at all times tangent to the circle. The body starts at point A and proceeds to B, then C. Find the change in the velocity vector between A and B and between B and C. Next. Algebraic approach. Adding vector quantities at right angles. Pythagorean theorem can be used to calculate a resultant vector when two perpendicular vectors are added or subtracted, assuming that the two vector quantities are horizontal and vertical, but the principle is the same as long as they are perpendicular. Figure shows two perpendicular velocities v1 and v2. They form a parallelogram that is a rectangle. The magnitude of the resultant velocity is, according to Pythagorean theorem, equal to this one. The resultant velocity makes at angle theta to the horizontal given by a trigonometrical formula, and you can solve this in this way. Notice that the order of adding the two vectors makes no difference to the length or the direction of the resultant. For example, a walker walks 4 kilometers due to west from his starting point. He then stops before walking 3 kilometers due north at the end of his journey. How far is the walker from the starting point? You can use this previous formula according to the Pythagorean theorem at right angle, because two vectors at right angle, you can use this other side as a resultant, and you can calculate in this way. It's equal to 5 kilometers, and the theta is 36.9 degree. It's calculated. Resolving vectors. The force has been resolved into horizontal components equal to F cosine theta and the vertical component equal to F sinus theta. It's similar with from mass. For example, an ice hockey puck is struck at a constant speed of 40 meters per second and an angle 60 degrees. To the longer side of an ice rink. How far will the puck have traveled in directions parallel and perpendicular to the long side after half second? Solution, you can use this one at right angle. You can use previous knowledge about this, and resolving parallel to long side is x component equal to v cosine 60 degrees, and you can replace the you can replace the what was you are given v x component equal to 30 cosine 60 degrees. It's equal to 20 meters per second. Distance traveled is equal to, it's because the uniformly motion xt equal to 10 meters. A resolving parallel to shorter side, it's v sinus 60 degrees. Y component x equal to 40 cosine 60 degrees. It's equal to 34.6 meters per second. Distance traveled by y on y-axis, it's of course uniformly motion. Therefore, distance traveled equal to v times t. 34.6 multiplied by half, it is time equal to 17 meters. Just to demonstrate that resolving in the reverse of adding the components, we can use Pythagorean theorem to add together our two components, giving total speed. It's equal to about 40 meters per second. If precisely, it's 39.96 meters per second. As the value for Vy was rounded, this gives the expected 40 meters per second. Adding vector quantities as a knot at a right angle. You can use these components. to sum up, I think it's today's my explanation about vectors and quantities will help for your in future lessons. Thank you for your attention.